Okay, so basically today what we're doing is we're going to graph the antiderivative, and to graph it we have to have a graph, and we have to have the first derivative test. The first derivative test basically determines whether an inflection point is a maximum, minimum, or neither. And the second derivative test is to find the increasing function, decreasing function, and the critical number. Okay, so we're gonna start off with the sine graph, and the starting point is 0, 0. First, I'm gonna put the critical points down, which is negative 2, 0, and 2. And since this is in the negative region, it's gonna be negative, and this is in the positive region, it's positive. Since this is a critical number, minimum and a maximum, it's gonna be 0 at that point. And since there's a 0 on the first graph and the second derivative graph, there's going to be a maximum there. So yeah, it looks like a negative cosine graph. The critical points are 2, negative 2, negative 1, and 1. So I'm just boxing it off because it makes it easier to look at for me. And yeah, so from negative 1 to 1, it's in the positive region. From negative 2 to negative 1 is in the negative region, as well as in 1 to 2 in the negative region. So put a positive right here, a negative right here, and a negative over here. Basically this is going to tell us our concavity, so it's going to be concaving downward from negative 2 to negative 1, upward from negative 1 to 1, and downward from 1 to 2. Alright, so we have enough information to graph the first one. It says the starting point's at 0, 0, so we know that it says 0, 0. Since the concavity changes at negative 1, there's going to be an inflection point there. So it's going to concave downward and then concave upward. And then there's also an inflection point at 1, so yeah. This is the antiderivative graph. This is the second derivative graph. And this one's the first. So yeah, that's how you graph antiderivatives.
Here's another example of how to graph antiderivative graphs. Here we have a derivative graph, and the first step to start to graph the antiderivative graph is to do a first derivative test of the given derivative graph. And to do that, to make a number line and put input into the domains as your endpoints. So it's for here 0 to pi, and the you put in between are the critical numbers, which are the zeros of that graph. And here you can see for 0 there's only 1 0 in between the setting, so we're gonna put that down, and we see that it's pi. And basically is that in the first derivative graph we know the first derivative is the slope is the graph of the slopes of the original graph. And so if the graph looks below the y-axis in the first derivative graph, then the slope is minus. The slope if the graph looks above the x-axis, then it's actually positive in the original slope, and we can get a minimum point or a maximum point. And here we get a minimum point. The second step is actually to graph a second derivative graph, which is just a derivative of your first derivative graph. And you're going to basically repeat the same steps. You're going to make a second derivative test. And to graph this second derivative, you actually have to look at the slopes of the first derivative graph. As you can see, from 0 to pi and a half, it's going down 1, like negative 1. And after pi and a half, it increases to 1 all the way until it gets 3 pi and a half. And then it goes back to negative 1 until it reaches 2 pi. So we see that pi and a half and 3 pi are my minimum and maximum points, so there are zeros. As you can see, it's the same thing, but instead of me parabolas, I'm making tick marks, and the tick mark is facing down. We know that in the original graph we're gonna have a concave down until we reach that point, and we see a tick mark that's facing up. Then we're having a concave up on the graph until it reaches another point, and that's what these points are called. They're called our inflection points on our original graph. So with all this information, we're ready to graph a possible graph of the derivative. and we know it starts at 1, 0 based on the givens. And the first thing we know is that the graph negative from 0 to pi and a half. So we know the graph is going to have a negative slope, and by the second derivative test, we know that the graph is going to have a concave down until it reaches pi and a half. And when it reaches pi and a half, it's going to have a concave up. And it's not until pi that the graph slope starts increasing, giving it a minimum point, and it continues to be concave up and just 3 pi and a half, and it becomes a concave up until it reaches 2 pi, and it ends at 2 pi because those are our set and that's how you graph a possible graph of an antiderivative.